Tonight's homework is about topographic maps, and topographic maps takes those land features that we talked about in class and actually puts those land features onto a map so you can see elevation, so you can see how high something is or how low something is. So again, like in the other previous flip classes that we've done, the flip lessons, you are to watch the video, pay attention, and then fill in the notes that you were given today in class. So again, focus on the right-hand side like normal, and I want you to pause if needed, and stop it if needed, rewind if needed. Topography is the study of the Earth's surface, shape, and features. So when talking about the Earth's shape and features, you're talking about mountains, valleys, the highs and lows. And what I want to show you here is just a flyby. This is over Death Valley, California. And if you were to see and fly through there, you could see those physical features of Earth. You can see how it looks like there's some lift there. You can see how it looks like there's some lower places. So that's what topography is. Topography shows these physical features, these land features in terms of their height above or below sea level. A topographic map is one that uses contour lines to show geographical features like hills, valleys, and mountains. And this is a topographical map. So what you have all these lines that show up, and those lines represent certain elevations. So when comparing a topographic map to a satellite map, here is a picture, an aerial photo that's taken, and if you look at it, it looks like there's some areas where there could be water. It looks like there's some areas where you have higher peaks than normal. If you look at a topographic map of this same picture, you can see there's a whole lot of lines, and those lines are called contour lines. And when you put the two together, you can see where those contour lines on the map kind of go along with the flow of the different elevations that are part of the real map. So again, here's an aerial photo of that place, a topographic map of that place, and then when you're able to see the two, you can compare the pattern of the contour lines around the features of the photograph. You can see then you've got some hills. You did see this crack that ran through the aerial photo right here. There's your dry stream bed, and then right here what looks like a tree branch is a road. So when you're able to see that, when you see the topographic map over the photo, you're able to see that using the symbols that are on the map as well. And that's what a topographic map basically does, is it shows you those geographic features. And it used those circles, and those circles are called contour lines. And what a contour line is, it shows a line of elevation. Elevation is the height of a point above or below sea level. So when dealing with an elevation, you can see here's the sea level, and then you can see the different areas that's right up above sea level. That's what you're dealing with when talking about elevation. What a contour line does is it draws a line of equal elevation. So you can see these lines right here on the map, how they are turning according to the feature of the land and what's going on there. Basically, if you were to walk along this entire line, it would be a certain elevation the entire time. So for example, this line right here is at 700. That means if I walked along this entire place, I wouldn't be going uphill or downhill. It would be 700 feet above sea level the entire walk. Same with this one right here. It would be 800 feet above sea level the entire walk along that contour level. You are not going uphill or downhill. Sometimes you'll hear topographic maps also called contour maps because of those contour lines. Now a contour interval is the difference between two adjacent contour lines. So here is a line, a contour line. An adjacent contour line would be either this one or it would be this one beside it. So it's basically that line that's beside it, and you have to figure out what the interval is, just like when we talked about intervals on graphs, which is like when we talk about the differences between the distances on a graduated cylinder, on a beaker. Topographic maps have intervals, and it's based on the distance between these contour lines. So if this line right here is 700, this line right here is 800, then you have to figure out what each one of these are. Well, I've got 1, 2, 3, 4, and then the 800. So if you can take 100 and divide it by that many lines, then you know you're going to end up with this being 720. This would be 740, 760, 780, and 800. That's what your contour interval tells you. It tells you the distance between each of the contour lines. So let's look at this from another point of view. Here what you have is you have a topographic map, and you can see that some of the lines are further away from each other. Some of the lines are really close to each other. And if we were to take this area, which here is a 3D version of it, and we were to simulate flooding, you could see where the water would reach at each of those contour intervals, at each of those contour lines, until it completely floods the entire area. Now, if you were to take water and you were to let it evaporate or let it roll down certain areas, you can see by going through where the water is moving, and as the water goes down, where there might be some weathering, some erosion, some deposition that takes place that would change the contour levels and the contour maps. Here's another example of looking at a topographic map. Here what you have is the topographic map over here, and then this is just a 3D model. And you can see the elevation that's there. Here is your elevation. As you turn the map, you can kind of see where there's some areas where it might be steeper in places, and you can see that, and you can pull it up where you can see the steepness. This one also, as you turn it, as you turn it, you can see some other areas of steep places. But basically what you have here is you have a 3D model showing what this would look like. And that, I gotta get it to straighten up. There we go. Showing what this topographic map looks like. Another sample of that is through this type of map. This is a pretty simple hill, what you have here. You can see all the lines are separated, and if you were to look at it, there's a couple little peaks here, which you can see right here. There's a circle and a circle showing a couple of those peaks. This is another look at a contour line, and excuse me, not a contour line, but a topographic map. And what you have here is you have a land feature that is going in and not up. If you were to look at this as a 3D model, you can see how the elevation is high on the outside, and then you have this crater type shape on the inside. What that is shown is called hatchers, and it's little lines that are pointing inward on a contour line, and I'll draw a picture of that so you can see the way that looks. But basically what you have is you have those areas that show that there's been a dip in the elevation. And then last but not least, I want to show you this picture, particularly this part in the square, in the box. If you look, you can see where land and the elevations are kind of turned at a point in this particular area. But if you compare that to the map right here, I keep going the wrong way. Right here is what it's talking about. And what easily could have happened You could have had something that melted. You could have had some water that ran off there and it dug into the landscape and created this formation. So when you see these type of points within a contour line, it's not just this straight, easy movement. You've got probably a river that's run through it or a stream that's run through it. Okay, moving on with our notes. The rules of topographic maps. The rules of topographic maps. First of all, you need to understand that every contour line has equal elevation. If you were to physically walk along a contour line, you would not be walking uphill, you would not be walking downhill. Number 2, contour lines never cross. Contour lines never cross because they are showing that that one point only has one elevation. Now, if you had another point, then you're dealing with another contour line. Number 3, every fifth contour line is bolded and labeled, which helps you as a map reader to try and figure out what it is that you're looking at in terms of elevation. Number 4, adjacent contour lines are separated by constant difference in elevation. And number 5, the difference in elevation is called the contour interval. Now, key to this information is the following 2 statements at the bottom. It says the wider the distance between the contour lines, the flatter the area. And the closer the distance is between the contour lines, the steeper the area. And what I want to show you is what T.A. Howard is sitting on. This is a sample of a satellite map. This is our school. This is our football field. What you have here is a satellite map of T.A. Howard. Now, the reason why people would want to look at topographic maps, building purposes, you would want to make sure that you could build on a flat surface. It makes building a lot easier. Maybe you're going to be doing some hiking and you're not interested in spending your entire hike going uphill the whole time. So a lot of different reasons. Those are just 2 of many for the reasons for looking at these topographic maps. This is your satellite map. This is T.A. Howard looking at a topographic map. Here you can see the contour line. Here you can see the contour line. Notice how these contour intervals are spread very far apart. If you think about the land out here, outside our school, it's pretty flat. There's not a whole lot of hills. Now, another way of seeing this and being able to see the hills is looking at Golden, Colorado. Colorado, as you all know, our big Rocky Mountain range that's there. Here's Golden, Colorado, which is right at the edge of a mountain range, and you can see what looks like the elevation of different mountains here. You can see some different other earth features. When I change the satellite map to a topographic map, notice these contour intervals. Look how close they are together. You can see others that are so close together, you know it's a very steep part of the mountain. Golden is a town that's built right down at the bottom of that mountain, which makes sense because it'd be a lot harder to build an area on a mountain. It's a lot easier to build that city, that town at the bottom of the mountain. So these are just some samples that I wanted you guys to see. Tomorrow what we're going to be doing is we're going to practice drawing some. We are going to practice reading some, and then we will have a lab where you're going to create a topographic map using true, real data. I hope that you now take the time to finish up your questions, that you finish up the summary, and I will be on spring break leave beginning Friday night, enjoying my sleeping in time, and I'm sure you will be enjoying your sleeping in time. See you guys tomorrow.